Okay, let's simplify rational expression. So we have 9 minus 4a to power negative 2, 3a to power negative 1 half, plus 2a to power negative 3 over 2, minus 1 plus a to power negative 1 minus 6a to power negative 2, a to power negative 1 half, plus 3a to power negative 3 over 2. Okay, let me write down this format, it works better, huh? Okay, and all this to power 4. So first of all, let's figure out domain, since we have rational expression. What is going to be our domain? So a cannot be equal 0, right? Because the denominator will become 0. Also, a cannot be equal negative 3. If you solve this denominator, you will get it as negative 3. And a cannot be equal negative 2/3. If you are wondering how I got these at the values of a that cannot be, because at these values it will become 0, it's very simple. I just did put 3a to power negative 1 half plus 2a to power negative 3 over 2 cannot be equal 0. And here a to power negative 1 half plus 3a to power negative 3 over 2 cannot be equal 0. Let me rewrite this again. This negative looks like part of fraction. Okay, so from here, first one, let me solve first one and then second one. 3 over a to power 1 half plus 2 over a to power 3 over 2, because we have negative exponent. And just to remind you real quick, a to power negative m is equal 1 over a to power positive m, yes? Okay, and this is cannot be equal 0. So we need to bring to common denominator 1 over 2 and 3 over 2, which means the common denominator is going to be 3 over 2. Why? Because here we have 1 over 2 and 3 over 2 is 1 and 1 over 2. This is greater than a to power 3 over 2. It's going to be our denominator. So a 3 over 2, let's see how many times it's going to fit. A 3 over 2, if I divide by a to 1 half, it's going to be equal a to power 3 over 2 minus 1 half. Yes, because, let me see if I can squeeze it down. Yeah, it did work. Because when we divide exponents, a to power m divided by a to power n, we need to subtract exponents. So here 3 over 2 minus 1 over 2, and it's going to be a to power 3 minus 1, 2 over 2, which is going to be equal a. This is gone. Which means here I'm going to multiply by a, right, to get a 3 over 2. Here also multiply by a. In second fraction, I don't touch it. All right? And we are getting here 3a. Well, I can drop this denominator because they are equal. plus 2 cannot be equal 0, right? And 3a cannot be equal negative 2. A cannot be equal negative 2/3. The same way you can solve the second one. It's like 1 over a to power negative 1/2 plus 3 over a to power negative 3/2 cannot be equal 0. Okay, so what do we have? Oops, excuse me. Okay, much better. So 1/2 and 3/2, again, it's going to be 3/2. The degree, here we multiply by a, here also we multiply by a. Let me move this closer. Okay. And we are getting common denominator. It's going to be a to power 3/2, and numerator we get a plus 3 cannot be equal. Well, because it's a common denominator, I didn't show in the first one. Let me show here. So I have to bring to common denominator here also, a to power 3/2. And I didn't put here anything. Okay, also times a to power 3/2. But because it's 0, so it's going to be 0. I drop denominator because it's the same. And I'm getting a plus 3 is equal 0. A cannot be equal negative 3, which you see. And a cannot be equal 0. That's obvious because everywhere we have only a. If a is 0, the entire denominator is 0. So let me make it more organize this piece, because I'm going to keep it. It's part of our problem domain. Okay, once we have it, let's start solving. So let me write down. So we have 9 minus 4 a to power negative 2. Here we have 3a to power negative 1/2 plus 2a to power negative 3/2 minus a to power negative 1/2 plus 3a to power negative 3/2 in numerator 1 plus a to power negative 1, yes, and minus 6 a to power negative 2, and all these to power 4. Okay, let's start working. So this is gonna be equal 9 minus 4 over a squared, right? Here I have 3 over a to power 1/2. This denominator part I already solved it, but that doesn't matter. 2 over a to power 3/2 minus 1 plus 1 over a minus 6 over a squared. Yes, 3 in denominator. What do we have? We have 1 over a to power 1/2 plus 3 over a to power 3/2. And all this in power 4. So next, so let's see, numerator I'm bringing to common denominator. So I'm solving this piece, bringing to common denominator. So we have a squared, so which means 9 also I have to multiply and divide by a squared, and I will get 9a squared minus 4. Denominator is going to be the same way, so I'm not going to explain again because I went over here. Common denominator, it's going to be a to power 3/2 which is going to give me here 3a. Remember, we multiply and divide by a, plus 2, and minus. Here we are going to bring to common denominator. Okay, let me write down here real quick, a squared here times a squared here. So we got same denominator. So here also common denominator is going to be what? A squared, which means we divide here by a squared and multiply by a squared, right? Here multiply only by a because we have a. All right. And here also we multiply only by a because a times a here, power 1 times a to power 1, 2. I'm going to add, right? 1 plus 1 half. And we are getting a to power 3 over 2. So therefore here also multiply by a. And the same thing I did here also, multiply by a, multiply by a. Okay. And we are getting here a squared, and here we get a squared plus a minus 6. In denominator, we get a plus 3 over a to power 3 over 2. And all this to power 4. All right, next. This is equal. What we're gonna do now, I'm going, since I have here subtraction, so I'm going to divide these fractions, which means 9a squared minus 4 divided by a squared. So if I divide, that means I multiply and flip a to power 3 over 2 divided by 3a plus 2, right? Minus, same operation I'm doing here. So it's going to be a squared plus a minus 6 over a squared multiply, so flipping over fraction because we do division, a to power 3 over 2 divided by a plus 3, and all this to power 4. All right, next, what is going to happen here? So a to power 3 over 2, a to power 2. So a squared, so we have a to power 3 over 2 divided by a squared. It's going to be a. 3 over 2 is 1 and 1/2, minus 2, right? It's going to be equal how much? It's going to be equal 2 minus 1 is 1. It's going to be negative 1/2, right? So negative 1/2, it's, all right, this will be gone. Here we will have negative 1/2. Okay. What else we have here? 9 a squared minus 4 is going to be, let me open this up. This is equal nine a squared minus 4. It's like a squared minus b squared. A minus b, a plus b. It's going to be 3a minus 2. 3a plus 2. And I'm going to cancel 3a plus 2. So let me write down clean what I'm going to have here. 3a minus 2. And a to power negative 1/2. I'm going to write down here denominator a to power 1/2. This negative sign, it's gonna bring down. Yes, minus. Now let's simplify here. See what we are going to get in this case. So a plus a minus 6. Let me see. I can break this down as so let me break down here. This is gonna be a plus 3 times a minus 2, right? 3 times negative 2 is negative 6, and 3 minus 2 is 1. Write down this a. Okay, now a plus 3 is gonna be gone with this a plus 3, yes? Now what else do we have? A squared, a to power 3 over 2. It's gonna be same way, so instead of 3 over 2 we will have negative 1/2, and the result is we are going to get a minus 2 divided by a to power 1/2, and all these to power 4. And we are getting, once I bring to common denominator, and denominator is going to be same, a to power 1/2. So practically I'm writing down the way it is, numerator. Now, one thing is very important. When you have negative sign in front of fraction, you treat that sign as if it's a negative sign in front of parentheses, which means it's going to flip every single sign in numerator. So a was positive, is going to become negative. 2 was negative, is going to become positive. It's very important to remember that. So what is happening? This is gone. Here we have 4. And we are getting what? Equal to a over a to power 1/2 to power 4. Right? And we are getting a and a divided the a to power 1/2. It's going to be, this is going to be gone. Here we will have left 1/2. Right? 1, because look here, a divided by a to 1/2. This is 1, right? It's going to be a 1 minus 1/2. So in numerator will stay 1/2. And the result is 2a to power 1/2 raised to power 4. And we are getting 2 to power 4 times a to power 1/2 to power 4. So we are getting what? 2 to power 4 is 16, and a to power 1/2 times 4, right? Power to power, we multiply. This is 1, this is 2. And the final answer is 16a squared. And this is our answer. Okay, let's do another simplification. Number 2. We have 4ab plus, this one is also a nasty one, plus a over b. And nasty problems are my favorite, usually. And stop laughing. Plus, times a to power 3. All right, so we are getting square root a plus square root b to power 2 minus 2 square root ab minus, here we have n exponents and square roots. So we have nice bouquet of everything. So here we get 2b square root a, in numerator square root a plus square root b, and to power -1. This is most for students who love math. 2a square root b square root a plus square root b, and to power -1. Okay, what we have in denominator? I have a plus, here I have square root ab over 2 plus b plus square root ab over 2. This is going to be -1. This is also going to be -1. So in this case, it's going to be easy to figure out domain. All is going to be a and b have to be greater than 0. So our domain, I put as a D, a greater than 0, b greater than 0. Okay, let's start solving. So this is going to be equal. Let's see what we are going to do. 4ab plus 1 plus, since I have here power -3, right? I'm going to flip, make it positive, and distribute this cube. It's going to be b cubed, oops, I'm sorry, b cubed divided by a cubed, right? I distribute it and flip it because negative sign. So when you have negative negative exponent, denominator comes to numerator, numerator goes to denominator. That is the rule, based on the property of negative exponent. Okay, times a cubed. And here so far I will leave the way it is. A plus square root b squared minus 2 square root ab. Okay, next, minus let's see what we have here. So second fraction, I have degree -1, which means I'm going to flip denominator with numerator. So we are going to have here square root a plus square root b. In numerator I will have 2b square root a, and plus here we have square root a plus square root b, and in numerator we will have 2a square root b, right? And in denominator we are going to have 2, again we are flipping because we have -1, right? So it's going to be 2 over a plus square root ab, and plus 2 over b plus square root ab. Okay, next from here we have 4ab plus, I'm going to simplify this fraction here. So 1 plus b cubed over a cubed, it's going to be common denominator a cubed, right? And here it's going to be a cubed here also times a cubed, because there was no denominator. I'm going to write down denominator a cubed. And we are getting here a cubed plus b cubed times a cubed, which is going to cancel right away, right? And in denominator, what am I going to get in denominator? Square root a plus square root b squared minus 2 square root ab. Okay, let's open square root a plus square root b squared. It's going to be square root a squared. Let me do drafting here so we can write down their clean answer. So let me see. Square root a plus square root b squared and minus 2 square root ab. So this is a plus b squared. We are getting square root a squared plus 2 times square root ab and plus square root b squared, right? And minus 2 square root ab. So this is gone, right? And we are getting square root a squared is a, square root b squared is b. So the answer here is going to be a plus b, right? Okay. Next. Minus. Let's see what we are going to do here. It's going to be more of the mess here. Common denominator is going to be square root a plus square root b. And in numerator, we are going to get 2b square root a plus 2a square root b. Okay, in denominator, we are going to get okay, we have a plus b and b plus a plus ab and b plus ab, which means I have to multiply by each other. Yes. All right. So it's gonna be this one. I'm going to multiply by b times plus square root ab. Right. Same thing accordingly here. And this one I have to multiply by a plus square root ab. And accordingly, same here, a plus square root ab. And as a result, we are going to get here, if I multiply, distribute, I'm getting 2b plus 2 square root ab and plus 2a plus 2 square root ab. And this is divided by a plus square root ab, b plus square root ab. Okay, well, we need to do cleaning there. Okay, we will do it. So it's equal 4ab plus a cubed plus b cubed over a plus b minus, so we're going to divide the second fraction, divide by each other. So this one, in numerator 2 is a common factor, so I'm going to take out, it's going to be 2b square root a plus a square root b divided by square root a plus square root b. Yes. And then I'm going to flip the fraction, a plus square root ab times b plus square root ab. So practically this fraction I'm dividing by this fraction. Yes? Okay. In denominator, what do I have? 2b, there are two of them, 2 square root ab, it's going to be plus 4 square root ab, and plus 2a. Look what is interesting I found here. 2b plus 4 square root ab plus 2a. 2b I can represent as square root 2b to power 2 plus 2 times square root, let me see, okay, let me put this one first, square root 2a squared, and now times 2 times 2b times 2a. So I got here a squared, a plus b squared. So from here I'm getting square root 2b plus square root 2a squared. Yes? Okay, so let me clean this one. Excuse me. Moving here, so this is gonna be this 2b plus 4 square root ab plus 2a, it's gonna be replaced with this one. Yes? Okay, so how are we gonna now simplify? Is there anything to simplify here? Let me see. Square root ab, square root ba. Well, let me write down this first one, first fraction, 4ab plus oh, I didn't even pay attention. This I can cancel with this. Beautiful. AB plus a squared minus AB plus b squared. So minus, so let's do the numerator, work out this numerator, this one. Okay. It's gonna be, let me see what I'm doing. 2 square root AB taking out. Here it's gonna be square root of b plus square root of a, right? How did I do that? Because if I have b square root of a divided by square root ab, right? The square root a and square root a is gone, and square root b is gone with this b, will be left square root b. Okay, that's how I did. And in denominator I am getting square root a plus square root b. Why I did it? Because so I will have this see, in denominator and numerator I got the same expression, square root b plus square root a, which will cancel each other. Yes. Now let's do in this this fraction, then I'm in denominator. So since it's division, so I'm going to flip the fraction. And let's multiply these two parentheses, right? Let's see what we're gonna get here. It's gonna be AB times A square root AB, and then plus B square root AB, and plus AB times AB, right? This one. AB times AB, which is going to be AB without square root. Yes? Okay. Now in denominator, what we're going to have, this one. Let me do here drafting real quick. So we have 2b, okay, 2b plus 4 square root ab, because there are two of them, 1 and 2, right? And plus 2a. If you look, this is a plus b squared, which is going to be square root. Let me take these two out. I will have b plus 2 square root ab plus 2a. Yes, let me put these 2 in denominator here until, otherwise I will forget. And I will have here, this is going to be square root b squared plus square root a squared and plus 2 square root ab. See that? So I'm getting here twice square root b plus square root a squared. Yes? Okay. And let's see what we are getting here. So these 2 I'm canceling with these 2. Let me write down clean. It's equal 4ab plus a squared minus ab plus b squared. Actually, these 2 like terms. Let me put here 3ab and get over it, not to deal with it anymore. Okay. Next, minus, I have here square root ab left, right? Now here in numerator, I have what? 2ab and plus a square root ab plus b square root ab divided by square root b plus square root a squared. Okay? This is equal 3ab plus a squared plus b squared minus square root ab. Here I have square root b plus square root a squared. Now let in numerator, I'm going to take also square root ab out. So from 2ab, if I take square root ab, I will have left 2 square root ab, right? Next, a square root ab, I'm doing this one, guys, just so you won't wonder. A square root ab, if I take square root ab, it's going to be a left over, and here will be b left over. Okay. So from here, this 2 square root ab plus a plus b, this is going to be square root a plus square root b squared. Yes? 2 square root the ab plus a plus b, 2 square root a plus square root b. And from here, let me rewrite 3ab plus a squared plus b squared minus, so a times b, it's going to be ab, right? And this one is going to be square root a plus square root b squared. And here we have square root b plus square root a squared. This is going to cancel each other. And we are going to have, so 3ab plus a squared plus b squared minus ab. And from here, we get like terms, a squared plus 2ab plus b squared, which is going to be a plus b squared. Whew, that was something else. I finished. Look at that. Okay, we are finally done. Anyway, thank you for watching. I see you in next video.